In January of 1986, Voyager 2 approached the Uranian system after a 9-year, 1.8 billion mile journey through our solar system. Voyager 2 had come out of cosmic hibernation to explore Uranus, the seventh planet from our Sun. In the next 10 hours, we would learn more about Uranus from Voyager 2's radio transmissions than we had in the previous 200 years of scientific study from Earth, including the discovery of 10 new moons and 3 more Uranian rings. Uranus had remained totally hidden until its discovery by William Herschel in 1781. Herschel was mapping the stars with his newly developed telescope when he spied an eerie, pale blue planet like no other in our solar system. Uranus's unusual color results from the absorption of red light by a high concentration of methane gas in its deep, cold, and remarkably clear atmosphere. This false color Voyager picture shows a discrete cloud seen as a bright streak at the upper right of the planet. The cloud's discovery was made possible by a series of Voyager images shuttered through violet, blue, and orange filters. Each of these color images shows the cloud to a different degree. In a true color image, the cloud would be barely discernible. The darker shadings at the upper right of the planet correspond to its day-night boundary. Beyond this boundary lies the hidden northern hemisphere, which remains in total darkness as the planet rotates. This is caused because Uranus, unlike any other planet, does not rotate about its poles, but rather on its side. This means that its southern pole always faces the sun, and its northern pole always faces away. Many scientists believe that a speeding cosmic bullet about the size of Earth struck Uranus and caused it to tilt over. Using Earth as an example, the Uranian southern pole would be approximately where Los Angeles is, and the northern pole would be in the Indian Ocean off the coast of Madagascar. Another strange discovery by Voyager 2 was that Uranus's hidden northern pole is actually warmer than the South Pole. This oddity is caused by some unknown internal heating process. Uranus does not exhibit any seasonal characteristics. Its temperature only fluctuates 3 degrees about its average surface temperature of minus 350 degrees Fahrenheit. Its rotation is extremely fast. 1 Uranian day is equivalent to 16 hours on Earth. This ice-laden planet, which is 4 times the size of Earth, has a unique system of rings. In this false color image, showing all 9 rings, we can see the 3 newly discovered innermost rings near the bottom in faint off-white tones. The outermost and brightest ring is known as Epsilon. Uranus's rings contain much larger and distinctly different particles than had been seen in Saturn's rings. The Uranian rings contain particles that are 10 times larger, measuring a meter or more in diameter than Saturn's marble-sized particles. Uranus's rings, blacker than coal dust, are one of the true wonders of space. Unlike the wide, symmetrical bracelets of icy particles circling Saturn, these rings are warped, tilted, and bizarrely elliptical and can vary in width by many miles. Uranus's gravitational pull, which was used to redirect Voyager 2 towards its next encounter with Neptune, also brought the spacecraft very close to the 5 previously known Uranian moons. Voyager 2 made its closest encounter with any of the moons when it flew by Miranda at a distance of approximately 18,000 miles. This innermost large moon shows unusual chevron features in regions of distinctly grooved terrain. Some of these grooved patterns indicate cliffs up to 3 miles high, higher than the walls of the Grand Canyon. Titania is Uranus's largest moon, with a diameter of more than 1,000 miles. One of the most prominent features of this moon is a fault valley that stretches for hundreds of miles and is 50 miles wide. In this valley, the sunward-facing walls are very bright. While this is due partly to the lighting angle, the brightness also indicates the presence of a lighter material, possibly young frost deposits. Another of Titania's distinguishing features is a massive, ancient crater formed during a violent period in Uranian history. Ariel is a densely pitted moon with craters 3 to 6 miles across. Numerous valleys and faults crisscross its pockmarked terrain. It is uncertain whether these sinuous features have been formed by faulting or by the flow of fluids. Some of Ariel's largest valleys are partially filled with younger, less heavily cratered deposits, giving scientists clues to its early development. Umbriel is the darkest of all the Uranian moons. It's largely featureless, except for numerous overlapping craters. This mystery satellite has an unusual white polar cap. Scientists believe that this bright spot was created when a large meteorite struck Umbriel, piercing its black, coal-like surface and exposing white ice, which was thrown to the surface, much like a terrestrial volcano spews up lava. Oberon is the second largest satellite in the Uranian system. It shows evidence, like many of the other moons, of meteorite impacts that have pulverized the gray surface, exposing an underlying layer of ice. Oberon's most distinguishing feature is a great peak towering 3 miles high on its lower limb. The tremendous amount of data on the Uranian system, sent back by Voyager 2, will challenge the scientific team of the Jet Propulsion Laboratory for many years to come. Meanwhile, Voyager 2 will go back into hibernation for its 3.5-year journey to its next encounter, Neptune. Voyager 2 will arrive at Neptune in August of 1989 and will attempt to unravel its many mysteries. But as with Uranus, many more new questions will arise. After a brief encounter with Neptune and its giant moon Triton, Voyager 2 will continue on through and eventually leave our solar system, becoming Earth's messenger to the universe.